Hi, I'm Dr. Mike Rofchek, the Loya and Edith Harris Assistant Professor of Computer Science at the University of Wyoming. Today, we're going to talk about two big features that computer programming languages and most computational devices have that really allow us to do powerful things. And so, I will start off by saying that this video has been made possible by funding from the National Science Foundation through a Research Experience for Teachers site grant called WySTACK. By the end of this presentation and the activity, we hope that you'll be able to describe and choose between two main methods available to control a computer program, or a computer in general, describe the various types of repetition structures available in many languages, and then also describe and use several operations in Boolean logic which are critical to control flow. If you want to, we also hope that you'll be able to execute and run some existing Python 3 code, as well as create and execute your own programs. Now, make sure that you recognize that we expect you to be able to do these things as a learner, not necessarily an expert. So, what separates, I'll say, basic calculator from a computational device? Two main things: storage of variables, storage of information, and the ability to make choices. Now, I will also mention that calculators today, even basic ones, do store the last thing you've done as a result so that you can reuse it, so that you don't have to re-enter all those items. And also, I will say modern day calculators, your TI 89s, your TI 86 pluses, all those are computational devices. So basic calculators are very different from computational devices, but modern day calculators really, they do a lot of the same thing. So making choices. So as humans, we make choices all the time, right? Our lives, we are making choices down to daily moments, the sequences in which we do things, the words I just chose, and even when we decide to take a drink of water. So other decisions though. How about, if it's freezing outside, then I'll wear a coat. Maybe something different. If it's below 32 degrees Fahrenheit outside, then I'll wear a coat. Or how about, if it's above 0 Fahrenheit and below 120 Fahrenheit, I will go outside. Otherwise, I will not. Okay, three different types of decisions using different types of information. In computers, really, there's two different ways to make choices, or decision-making modes. The first is thinking in terms of what we just saw there in the past. If-then statements, or if-then-else. If something holds true, then I will do this action. Otherwise, else, I'll do something else. So the most basic version is just an if-then, without the else. So just every statement saying, if something is true, then do something. If something else is true, do something else. The other big mechanism that's used to make decisions in computing programming languages are case switch statements. So basically you could think of this as having many options and selecting an outcome based off of a specific choice. So where this might happen is doing a case on for letters. So you could say, if A, then grade was between 90 and 100. If B, then grade was between 80 and 90. You might not really want to use it in that way, but another common place where this might happen is checking what letter was pressed and then doing something based off of what letter was pressed. So no one likes repeating oneself over and over again, right? So one of the huge, I'll say, differentiating features for programs, computers, is that they're really good at repetitive tasks. So repetition is critical in creating programming language, well, a program. So there are different types of repetition. So one is count controlled. Do something a fixed number of times. So this could be make 12 cookies. Your process for making a cookie is pretty much the same. It should be the same each time you're making a cookie, right? So you could think of the set of actions for making one cookie, do it 12 times. Count controlled. Another type of control is this idea of doing something until some condition is met, or while a condition is true. So you can imagine if we go back to our cookie example, you could, instead of making 12 cookies a fixed number of times, you could say, make cookies until the dough runs out. Or you could reframe that as, while dough remains, make cookies. Both of those lead to the same outcome, but those are controlled by a condition. The other thing we could do is we can iterate, repeat ourselves, for every item in a collection. So you imagine we've made these cookies. You could say, for each cookie, add icing. Right? So I've got a set of things. I want to do something to each one of those things in my set. That is collection controlled. I'll also mention that there is another special type of loop, and that is an infinite loop, a loop that just goes on and on and on forever. And you might say, well, when would that be needed? Well, so one of the things that some of the groups are using is a hardware device, a microbit, that runs a program over and over and over again. Your computing system is running a process over and over and over again, and it only stops when interrupted. So with that, what are these conditions that can control these if statements, these choice statements, and these loops? Well, in computers, there are basically true and false, binary truth statements. Most computing systems, almost all of them, I can't think of one right now that doesn't do this, true is also equivalent to 1, false is 0. And if we are looking broadly, generally the structure for things is if some condition, do X, or while some condition, do X. Well, that condition ultimately results in a truth statement. Is the condition that you're talking about true or false? So, if true, do X, while true, do Y. Both of those will do those things. Now, the alternative is if false, do Z. Z will never happen. We just said that this condition is false. We told the computer it's false. It will never run. Similarly, while false, do W. W will never happen because the condition is just set to false. Now, clearly these are, well, the if false and while false really are meaningless. They will never run ever. The if true and while true, the while true is an infinite loop. And the if true will always run, so it's kind of let's say a pointless conditional check, but it kind of is. There's no real reason to do that. But those are all valid. They're not very interesting, with the exception of the infinite loop, but these aren't really interesting. So these conditions that we're going to build up are probably, well, they're going to be a lot more interesting if we start actually looking at what those conditions are, which could be relationships and inequalities. So you could imagine doing a mathematical check inside of these. So you could check if some variable is less than or greater than, or less than or equal to, or greater than or equal to. And then there is a gotcha, or equal to. And the way we represent equality in most computer languages is with a double equal sign. So be really careful. A single equal is most often an assignment, meaning that you're setting something. So A equals 2 is setting A to the value of 2. A equal to is checking to see if A is equal to the number 2. So a little bit confusing there. Watch out with equality in the particular programming language that you're using. And then the last element here, not equal. So we can do these checks for relationships and equalities with variables, between variables, and other types of data. So actual numerical data, text data, characters. Where things get really interesting is when you start combining conditions. So the foundations of what we do in computing deals with logic. So the first primary one, negation, not. So if we have something called A and it has a truth value of false, not A would become true. So this truth table up here shows that. If it starts off as true and then you do not A, the result will be false. Other major conditional logic, Boolean logic expressions that we have the ability to do the union between A and B, which is represented by an or. And I will make mention that this is very different from our English or, in the sense that when we say I will go to the store or I will go home, we don't typically mean both of those things, right? We mean one or the other. But notice that in computing, that's not the case. The result of A or B in computing is true if A is true, if B is true, and if they're both true, the result is still true. The version in computing that is closer to our English OR is exclusive OR, which is basically true if and only if one of the two of these is true, A or B. You can see that in this truth table. The final thing that we do a lot of in terms of Boolean logic is AND, the intersection between two elements. So in this case, the only time that the intersection is true is if A and B are both true, then the result is true as well. So one last little bit before have you do an activity. General structure for loops in most programming languages looks like this. You have a for, and then a starting condition, stopping condition, and an increment. And then within your loop, the statements to execute. In Python, however, most of the loops are iterations over items in the list. And if you go back a few slides, you'll see that one of the types of iteration is for item in list, right? And so that's actually most Python for loops look like that. So the simplest one is for x in items is the structure, the syntax, and then you do something with x, whatever that is. Print it out, add numbers to it, add them up, whatever you want to do. You're doing that within your for loop. Now you're like, well, how would I do one that is fixed counting? Well, for x in range 5, for example, would let you do something with the numbers 0, 1, 2, 3, and 4. This is the quickest way to do a for loop that goes through and does something 5 times. Now, if you wanted to do something for a set of numbers that was slightly different, right? If the numbers actually matter, you can actually do a starting condition, starting at 2, going essentially not until 5, but through basically 2, 3, and 4. And then the final version, which is actually most similar to the very first one that we talked about, the general one, for x in range 2, 15, 5. So basically, our starting condition is we're starting at 2. We're going to stop once we reach 15 or go above 15, and we're going to increment by 5 at a time. So what numbers we're going to see are 2, 7, and 12. The next time through, we would add 5, and that would be 17, which is definitely bigger, and we wouldn't run that. So that was a whirlwind through the two major control mechanisms we have in programming languages, which are repetition and choices, right? So our choices are if-then statements, case statements potentially, and then essentially loops, ways to control flow, to repeat over and over again what we're doing. There are other structures, and for that, I'm actually going to tell you to go and head over to sololearn.com and go back to the place we were at last week. So if you didn't do last week's, go back over, get into SoloLearn, and you're going to work on the next 2 units, which are control structures and functions and modules. So take your time going through those, and if you need any help, we are available on Slack, and also use the replit.com link so that we can actually help you along as you code. SoloLearn.com doesn't have interactive capabilities, so if you're working on something and you're struggling, hop on over to Replit, work there, let us know how we can help you. All right, and there's that information again. We're on Slack and the WySTACK, and it's -C1 -prog support. Happy to help, and thanks for watching.